In last video, we discussed about the architecture of wireless sensor node. So in this video, we will discuss about the various characteristics of wireless sensor network. First, we'll talk about the sensors. So wireless sensor network mainly consists of sensors. So they will sense the measuring property and then the data will be converted into the corresponding electrical signals. So the sensors which we utilize in wireless sensor network, these sensors are low power devices because the energy is the constraint in wireless sensor node where the sensors are connected. So sensors are generally chosen in such a way that they consume low power. They will have limited memory so that the less energy can be consumed. They are small in size but large in number because they are deployed in field large in number. Energy is constrained because in the field they are mostly battery operated and they will not get the charging options in the field. So energy will always be constrained. The sensors are tetherless. Tetherless means the sensors will not be able to share the data communication with others. As we do in case of mobile, we use the tethering technique to share the mobile internet with the other devices such as computer and laptop. But that tethering capability will not be available in case of sensors. The sensors are low cost components. Now, wireless sensor network can be deployed in the extreme environmental conditions and may be prone to enemy attack. So, the external environment where these sensors are deployed, the conditions are very extreme. Say, for example, if they are deployed in the chemical processing plant, and since they are deployed in the field, they are prone to enemy attack also. Now, although they are deployed in ad hoc manner in the environment or in the sensing area, they need to be self-organized and self-healing. Self-organized means they will coordinate with each other for the data communication, and self-healing means even if one sensor node is dead, they will make sure that the communication path is not hampered. So in that way, they will search the nearby alive node and stabilize the communication through alternate path. The sensor nodes may not have global ID because they are deployed large in number in the particular environment. Nodes are generally battery operated. Now the wireless connection links are fragile and possibly asymmetric in case of wireless sensor nodes. The connectivity of the wireless connection depends on the power levels and fading. If the power level is very low, it is very difficult to stabilize the connections using wireless sensor nodes. So that's why the wireless sensor nodes are designed in such a way that they consume very less power for the data communication. Interference is high because the power level is low, and because of that, the antennas, which are mostly omnidirectional in case of wireless sensor node, they are very much prone to high interference. As far as energy saving is concerned, the wireless sensor nodes sleep as much as possible. Sometimes they sleep 99% of their useful life. They acquire data only if it is really necessary. They use various data fusion and compression techniques so that the large data can be transmitted in less time, and the energy in the data transmission can be saved. The transmission and reception from wireless sensor node happens only if it is necessary. The data receiving and the data transmission from the wireless sensor node is equally costly because the energy consumption in case of data receiving and the data sending is same. Scalability and reliability. Wireless sensor nodes should be self-configured and be robust to topology changes. Self-configured means the wireless sensor nodes should have the capability to configure themselves in such a way that the required communication path can be stabilized. So, using these self-configuration capability, they ensures the connectivity as well as the data coverage. Maintenance. Reprogramming is the only practical kind of maintenance because these are deployed in large geographical area where doing maintenance is very difficult task. So we can only do reprogramming for the maintenance purpose, which is also done wirelessly. Now let's talk about the data collection. So in case of the wireless sensor network, the centralized data collection puts extra burden on the nodes which are closer to the base station. So in that scenario, the nodes which are closer to base station have the greater responsibility to collect the data from the nodes which are spread in a geography, collect that data and then send data to the base station. So because of the greater responsibility of data collection and sharing of data with the base station, the edge nodes, the nodes which are nearer to base station face lot of extra burden. Now data is clustered sometimes. So the clustering is one kind of topology which is followed in wireless sensor network, and the topology we will discuss in the next video. So in case of clustering, the nodes are grouped in such a way that the central coordinator of that cluster will be responsible to consolidate the data from the nearer nodes, and then this central node will share the data with the far end node, that is edge node, and then the edge node will send data to the base station. So in that way, the number of connections with edge node will be lesser. So the clustering approach helps in fewer transmissions of the data. Often getting measurements from particular area is more important than getting data from each node. Because of this requirement, generally the number of nodes are very large in size in a particular geography, so that whichever node is alive at a time will share the data with the base station, because the requirement is to get the correct information from the area rather than getting data from each and every node. So lot of nodes which are responsible to collect the data will be sleeping sometime. So the nodes which are awake will take the responsibility to sense the parameters and send the data to the base station. Security and authenticity is a major concern in wireless sensor network because the sensor node cannot handle various encryption mechanism because of the memory size as well as the power constraints. However, the efforts are being made to make the wireless sensor nodes more secured using some simple encryption mechanisms. Signal power. So wireless sensor nodes have the sensitivity of signal as low as minus 110 dB. So the sensitivity is low means we will keep the signal strength as low as possible so that the power consumed in data transmission is minimum. Generally, we utilize narrowband FSK or spread spectrum communication for the data transmission. Most of the time, the data transmission happens through 802.15.4 protocol that is being given by IEEE. However, IEEE 802.15.4 doesn't have the network capability. Therefore, the ZigBee protocol is being proposed to route the data from the various nodes to the remote end. So we will discuss the ZigBee and other similar kind of communications when we will talk about Internet of Things. Here, mainly the wireless sensor nodes utilize ZigBee or Bluetooth kind of data communication technique for sending data to the remote end. It has relatively low rate of data transmission. Generally, even less than 100 kbps would be the speed of data transmission because the prime objective is to save power. The radio which is utilized in wireless sensor node is the commercially available chip. So it is cost effective and easily available, and it helps in keeping the overall cost of wireless sensor node as low as possible. Since we keep the wireless sensor nodes large in quantity in a particular geography, the cost is also an important factor. So that's why the components which are being used in the development of wireless sensor nodes should be cost effective. So the radio which supports various frequency ranges are part of ISM bands. So that is 902 to 928 megahertz. That is mainly used in US. 2.4 gigahertz and 5.8 gigahertz are the commonly used ISM band frequencies in Wi-Fi. In India, we also utilize 868 megahertz of frequency in ISM band for the data transmission. Another important characteristic of wireless sensor node is the address-free architecture. The advantage of having address-free architecture is that we can randomly select unique identifier at any time whenever we have a particular data transmission. The advantage of having address-free architecture is also that the wireless sensor nodes can be spatially as well as temporally located in the field. So whenever which node is awake, he will be given a temporal ID for the data transmission. Because of having address-free architecture, we have certain drawbacks. One of the major drawback is it is not applicable when the static addressing of nodes is needed. This is particularly applicable in those cases where the node has to send data to the remote server. So in that case, static addressing is required so that the server can authenticate the correct source of data transmission. Sometimes we also have the identifier conflicts because same ID can be available in different environments where the different sets of nodes are deployed. So every geographically located environment may have same type of the identifiers. Because of that, the data cannot be transmitted from one geographical area to other geographical area Now let's see the communication architecture, how the wireless sensor network is working on the field. So we will have the sensor network where various sensor nodes are deployed in the environment. So this environment is very large geographical area where the nodes are deployed, and then these nodes will use hopping from node A to the end user. The A will hop data to various intermediate nodes such as B, C, D, E, then send data over the network and then to the user. So in that way, the possibility of having alternate paths are there. So even if one node is dead, the alternate path can be utilized to share the data with the end user.